Hello my dear students, welcome back to the class. So in your previous class you have learnt about the Lorentz force, correct? Okay, and you got the expression for the force of the moving charge or the charge moving in the magnetic field also. That is F is equal to Q into V cross B of R. Am I right? Okay, this was the expression which you got. Do you know what is the unit of the magnetic field? The unit of the magnetic field is Tesla. Tesla. And the symbol is capital letter T. Or else the unit of the magnetic field is Gauss. Unit of the magnetic field is Gauss. Okay. See here. Magnetic field is said to be 1 Tesla. Magnetic field is said to be 1 Tesla when? Can you define 1 Tesla? Important 1 mark question. Define 1 Tesla. See here. What I will do is, I can also write this as Q into BV sin theta. Unit vector n cap, correct? Okay. If B has to be 1, then I can say B is equal to F by Q V sin theta into n cap. Correct? Correct? Then I can say for magnetic field is 1 Tesla, means force should be 1, charge should be 1, V should be 1, sin 90, correct, is 1. So I can say B is equal to 1 Tesla. How can we define it? Magnetic field is said to be 1 Tesla if or when the force acting on the unit charge placed perpendicular force acting on the unit charge placed perpendicular to the magnetic field with a speed of 1 meter per second is 1 Newton. With the speed of 1 meter per second is 1 Newton. See here, 1 Newton, Q is 1 coulomb, speed is 1 meter per second, and theta is equal to 90. Correct? See here, magnetic field is said to be 1 Tesla if the force acting on the unit charge placed perpendicular to the magnetic field with a speed of 1 meter per second, with the speed of 1 meter per second is 1 Newton. Is 1 Newton. The magnetic field is said to be 1 Tesla when a force experienced by a unit charge placed in perpendicular to the magnetic field with the velocity 1 meter per second is 1 Newton. Understood? Very, very important question for 1 mark. Is nothing but 1 Tesla. 1 Gauss is equal to 10 to the power minus 4 Tesla. 10 to the power minus 4 Tesla. And you should know that Earth's magnetic field is about 3.6 into 10 to the power minus 5 Tesla. This is Earth's magnetic field. Earth's magnetic field is 3.6 into 10 to the power minus 5 Tesla. Okay, and keep these points in your note point. Okay, that is 1 Gauss is equal to 10 to the power minus 4 Tesla. Earth's magnetic field is 3.6 into 10 to the power minus 5 Tesla. Next, one small derivation. Expression for the magnetic force on a current carrying conductor placed in a magnetic field. Or I can say magnetic force, so that you will not forget, correct? Placed in a magnetic field. Let us consider a rod. Okay, one rod we'll consider of a length L, area of cross section A, carrying the current I. Let us consider a rod of length L, area of cross section A, and current carrying the current I. Placed in the uniform magnetic field B. Let us place it in a uniform magnetic field B. Okay, B vector. B vector. Then let N be the number density. N be the number density of the charge carriers. Number density means what? Number of electrons per unit volume. N be the number density or number of electrons per unit volume. Okay. Then total number of the charges or charge carriers in it is total number of charge carriers in it is, see, N is the number of electrons per unit volume it is. For unit volume, N be the number of electrons. Then what is the total number of electrons or total number of the charge carriers? N by V into V, correct? But V, can I write it as A into L? Yes. Volume is equal to area into length. So I will write N A L. Correct? N is nothing but number of electrons. N means N by V. N by V into V is nothing but N. That is number of electrons. So total number of the charge carriers in it is N into A into L. Next, if Vd is the drift velocity, if Vd is the drift velocity of the charge carrier, then the force on this charge carrier is force on this charge carrier is, what is the force on these charge carriers? F is equal to, what we have written in the Lorentz force, one force expression we have written, no, that itself, that is F vector is equal to how much? N A L, n number of how many electrons? N A L into Q into V cross B. V is how much now? VD cross B vector. Correct? If there is only one electron, then 1 into Q into V cross B. Correct? Here, how many electrons, how many number of charges are there? NaL. So, NaL into Q into Vd cross B vector. Understood till here? Yes. Next. What is the next step I can move for? See here. F vector is equal to, I can open these brackets and can I write A L J. One J I will write. Okay, J vector cross B vector. J vector cross B vector. What is that? J. What do you mean by J? Sorry, J vector is equal to, what is J vector? N Q V D. NQVD is nothing but J vector. What is J vector? It is nothing but current density. Current density J is a vector. In the previous chapter we have learned current expression for the current density J vector is equal to NQV. Here it is VD. So in the place of NQVD I can write J. Remaining it is like this itself. Correct? Again I can write how? I into L vector cross B vector. That is I is equal to J vector into A. That is current density into A is nothing but I. I is equal to NEAVD. Do you remember? I is equal to NEAVD. A is here. NEA is this one. NEAVD. Correct? So I, in the place of JA, I can write I. So F is equal to L vector cross B vector. Now, L vector is a vector of the magnitude L. Vector of the magnitude L. Therefore, what is the expression we got? F vector is equal to I into L cross B vector. Correct? F vector is equal to I into L cross B vector, or F vector is equal to BIL sin theta into n cap. Bil sin theta into n cap. Correct? What we have done, let us consider a current carrying rod, or let us consider a rod of length L, area of cross section A, current I, magnetic field B. If n is the number density or number of electrons or number of charge carriers per unit volume, then total number of the charge carriers in it is NaL. If Vd is the drift velocity, then the force on these charge carriers is NaL into Q into V cross B, Vd cross B vector. Correct? We know that J is equal to NQVD. So I can write AL J vector into B vector. Correct? But J into A is nothing but I. So I is equal to L cross B vector, or else I can write F vector is equal to BIL sine theta into N cap. For the remembrance purpose, I will read it as Bil sine theta. F vector is equal to Bil sine theta. Very, very, very important formula for solving the problems. This derivation is also very, very, very important. Understood? So F vector is equal to Bil sine theta. Next, shall I move further? Can you help me? Yes. Do you remember the formula we learnt in the previous class? That is F is equal to QEB sin theta or QBV sin theta. Do you remember this formula? We said if theta is equal to 0, it is parallel. If theta is equal to 180, it is anti-parallel. Correct? Okay. If suppose theta is equal to 0, we said it is parallel. Then it should move straight line. Correct? If it should move in a straight line. So charged particle should move. When a charged particle moves parallel to the magnetic field, the trajectory is a straight line. If theta is equal to 0, then angle between B and V is 0. Correct? Then I can say the trajectory means path of the charged particle is straight line. The charged particle is moving in a straight line. Even if theta is equal to 180, it should move in angle between B and V. No, it is. It should move in a straight line, but in the opposite direction. That's all. Correct? So therefore, here also trajectory or path is straight line. Trajectory is a straight line. If suppose theta is equal to 90 degree, then if theta is equal to 90 degree, the trajectory is circle. Trajectory is circle. It will try to move in AC angle between this one and this one. If it is a 90 degree, then it will try to move in a circle. Correct? It will try to move in a circle. We can explain it in the next derivation. So when we solve the derivation next, you can understand it. So the trajectory of the charged particle moving in a direction, making an angle. If it is not making 90 also, neither 90 nor 0. 0 means, okay, angle is only not there, one upon the other. That is nothing but we said this one. If it is neither 0 nor 90 degree, then what is the trajectory? Then the trajectory is helix. See, these points and all important for your JEE and NEET. What happens when theta is equal to what? If theta is equal to 0, then its trajectory is a straight line. If theta is 180 also, the trajectory is a straight line. That is, path is straight line. But if theta is 90 degree, then the trajectory is a circle. If theta is not 0 also, not 90 also, somewhere in between, then it is helix, like a spring. How the spring is? Spring will not make complete circle, it will next change, correct? Change, like this, helix. Understood? So, if the theta is not equal to 0 or if it is neither 0 nor 90 degree, then the trajectory is helix. Please don't forget these points. Very, 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 very important. Next, we are going to find out the expression for the radius and angular frequency of the circular motion of a charged particle moving in a uniform magnetic field. Once again, I want to make you remember, if the magnetic field or electric field is coming out of the paper, then we represent it by a circle with a dot at the center. If the magnetic field or the electric field is going into the paper, then it is like this. In the next derivation, what we are going to do, we are going to draw the diagram using these symbols. Understood? I hope you will write notes properly. Please write that Fleming's left hand rule, thumb rule, Lorentz force, then these few note points, please write it in your notes. The derivation, important for 3 marks. Okay, that is F is equal to Bill sin theta derivation is very, very important for 3 marks. I hope you will learn it properly, and these formulas also very, very important for solving the problems. In the next class, we will learn about the radius. Okay, fine. Thank you.